everybody, and welcome to this video on mixed sequences. In this video, we're having a look at an exercise. The exercise requires us for each of these sequences, we have to determine the general formula and the 50th term. So let's get started. If you'd like, please pause the video and attempt it before you play the solution. So let's have a look at the first one. 1, 3, 5, 7. Now, before we can find the general formula, we have to find out what type of pattern is it. So we can divide, find a ratio. So 3 divided by 1 is 3. 5 divided by 3 is 5 over 3, and 7 divided is 7 over 5. So there is no common ratio, so it is not geometric. We can try subtracting different terms. So 3 minus 1 is 2, 5 minus 3 is 2, and 7 minus 3 is 2. So here we have a constant first difference. And what you should remember is that if it has a constant first difference, then what type of pattern are we dealing with? We're dealing with a linear pattern. And if it is a linear pattern, then the general formula follows Tn is equal to A plus n minus 1 times D. So we need to fill in what's the A and D. So the A is the first term. So there is our A, and sorry, it is 1. And our common difference is the D, so that is the D, and then we're going to then just simplify this. Okay, so we have Tn, we distribute that 2 to both terms, is 1 plus 2n minus 2, so we get that Tn is equal to 2n minus 1. And that is our general formula. To find the 50th term, that is quite simple. We then just use this general formula, and in the place of n, we put 50. So this is 100 minus 1. So the 50th term is 99. Okay, so those are the steps. We first determine what type of pattern it is. Then we use the corresponding general formula, and then we can substitute and solve. Let's have a look at the next one. Okay, so for number B, we have 2, 5, 10, 17, and so on. We can first try the common ratio. So 5 divided by 2 is 5 over 2. 10 divided by 2 is 2. 17 over 10 is the next one. So there's no common first difference. So what we can do is there's no common ratio, so it's not geometric. So we can look at differences. 5 minus 2 is 3, 10 minus 5 is 5, and 17 minus 10 is 7. So there's no common first difference. We can go for the second difference. 5 minus 3 is 2, and 7 minus 5 is 2. So it has a common second difference. So if it has a common second difference, it is quadratic. So then to find the general formula, we use those 3 formulas. And if you're not sure what we are talking about, please watch our quadratic series, sequence series. So we have the first formula we use is 2a is equal to our second difference. So that's the first formula that we use. So we get 2a is equal to 2, and we solve and we get a is equal to 1. The second formula we use is 3a plus b is equal to our first difference. So here's our first differences. We're looking for our first one, so that one over there. So this here is 3 times 1 plus b is equal to 3. So what we get is 3 plus b is equal to 3. So b is equal to 0. Okay, and then finally we use our third formula, which is a plus b plus c is equal to our first term. So our a value is 1. Our b value is 0, and we're solving for c, and our first term over there is 2. So then solving for C, we get C is equal to 1. Okay, so we then have that our general formula is Tn is equal to 1n squared plus 0n plus 1, which we can write as n squared plus 1. To find the 50th term, it is then 50 squared plus 1, which is 2,501. Okay, so that is that one. For the quadratic sequence, we use the different general form. We use the different formulas to find the general formula. Let's look at the third question. So over here we have number C, which is 4, 2, 1, a half. So let's divide. 2 divided by 4 is a half. 1 divided by 2 is a half divided by 1 is a half. So it has a common ratio, which means it's geometric, which means it follows the formula Tn is equal to ar to the power of n minus 1. And once again, we need to substitute the a, which is the first term, and the r, which is the common ratio. So let's do that. We have the first term is 4, and the common ratio is a half. So we have Tn is equal to that. We can write this as bases of 2, so that's 2 squared, and this is 2 to the power of minus 1, to the power of n minus 1. And we can then simplify that to 2 squared, 2 to the power of 1 minus n. We can multiply that all. So we get Tn is equal to 2 to the power of 3 minus n. So then T50 is 2 to the power of 3 minus 50, which is 2 to the power of minus 47. So we'll leave it in that form. Okay, so I hope you've understood these examples of finding the general formula and the 50th term. So to find the general formula, we first have to determine what type of sequence it is. Then we use the corresponding general formula for that type of sequence, substitute in the values for the one that we need, and then we can go ahead and find any term that we want to. If you were unsure about any of the work that we've covered, please look at our previous videos before watching these. Thank you for watching. Bye.